We are trying to set up a double integral to find the area of polar regions. Our polar equation is r equals to 3 times cosine of 3 theta, which is the graph right over here. So we want to find the area of all 3 petals. The strategy is I would like to set up a double integral to find the area of one petal and then take that area multiplied by 3. All right. So we are trying to find the area enclosed by the graph of this r equals to 3 cosine of 3 theta, and then we let the region r equals to 1 petal, and then the boundaries is that theta is between pi over 6 and negative pi over 6, and then the r is between 0 and 3 cosine 3 theta. So this one has a fixed boundaries for theta because the negative and the positive pi over 6 are fixed, they are not changing, and then the variable bounds for r. This is basically a polar equation, so the r is changing. All right, so we call this r simple region. So these 3 region, these 3 yellow region, we call this r simple region. Okay, and then before we start, sometimes the problem can change things a little bit. They can just let you find your own boundaries. So let's say I don't tell you this is from pi over 6 to negative pi over 6. How do you find out? In fact, that is a very good question to be put on a test. Let's just do these problems first, and then I will answer that questions for you, right? So let's say just the plus and the minus pi over 6 is not given. How do you do the math to find out? That is actually good to ask on a test. Okay, let's go back to the integral. So the integral that we will be doing is I am going to set up a double integral for this region R. So double integral, and then this is the dA for area, this region R. So that is a double integral. Okay, so let's do a double integral first. And then what is my polar equation? The polar equation is 3 times cosine of 3 theta. You know what? We are going to do a dr d theta integral. And then the integrand, watch, is just 1r only. Okay, where is the 3 cosine 3 theta? We put that in the upper and lower limit. So r is between 0 and 3 cosine of 3 theta. Oh, when you write your formal double integral, they do not write the r equal. But I think it is, since this is a dr, I believe it is more clear to present the r equal as well. And then for the d theta, I will also present that theta is negative pi over 6 to positive pi over 6. In my opinion, I think that is more clear. In math, you want to be clear, right? You don't want to be unclear. Okay, what do we do first? Simple. We will just integrate. So we will integrate the in the integral, which is the dr. So what is the integral of r? Just a simple problem. What is the integral of r? The integral of r is r squared and then times 1/2, right? So we have integral equal to integral from negative pi over 6 to positive pi over 6, and then we have our 1/2 r squared, right? And then such that r goes from 0 to 3 cosine of 3 theta, and then we have the outer differential, the d theta, and then you plug it in. So we have integral from negative pi over 6 to positive pi over 6, r squared. Should I take the 1/2 out? I believe I should. Okay, I should just leave the 1/2 right here, r squared. So that will be 9 times cosine square d theta, and then minus 0 square. And then I will just do it like this, and then do a d theta. Can we simplify something? Can we? Yep, we can do a 9 over 2, and then integral from negative pi over 6 to positive pi over 6, and then cosine square of 3 theta, and then d theta. This is also a good problem to discuss because you have to recall the formula of cosine square. You don't remember, that is fine. Let's recall that right now. Let's pick a different color. Let's pick a purple. So that formula is cosine square of 2x. Cosine square, no, actually it's cosine square of x. that is equals to 1 plus cosine of 2x divided by 2. This is from a double angle formula of cosine. And then if you have a cosine square of 3x, that means on the other side, you have to triple the number in front of x. So this will be 1 plus cosine of what? 6x divided by 2. You only triple the number right next to x. So returning to my problem, so we have a 9 over 2 and then integral from negative pi over 6 to positive pi over 6. And then we have the 1/2, right? You know what? The 1/2, let's just bring it out. And then we have a 1 plus cosine of 6 theta. And then a d theta. And then we take the 1/2 out, so that will be a 9 over 4. Now we integrate. The integral of 1 is equals to theta. And then the integral of cosine is sine. So we have a sine of 6 theta. What else? When you take the derivative of sine of 6 theta, by chain rule, there is a 6. So we have to prepare a 1 over 6 in front to get rid of the 6. And then this one has a fundamental theorem of calculus from negative pi over 6 to positive pi over 6. So we have 9 over 4. 9 over 4. And then first of all, we have a pi over 6 plus 1 over 6. Plug in a pi over 6, we have a sine of pi. Sine of pi. And then minus 9 over 4. And then we plug in a negative pi over 6. And then plus 1 over 6. Sine of negative pi. Sine of positive pi and negative pi is equals to what? Sine of pi is 180 degree is on the x-axis, so y is equals to 0. So basically the sine pi, the sine negative pi are all 0. So we have 9 pi over 24, right? And then plus 9 pi over 24. So the answer is equals to 3 pi over 4. So this is equals to 3 pi over 4. And I have to box that and say that this is only one pedal. So one pedal. One pedal. All right. And then how many pedals do we have? We have 3 pedals. So the total area is equals to 3 times 3 pi over 4, which is equals to 9 pi over 4. That is the area of all 3 pedals. All right. So the problem is done right here, and I have to return to my question at the very beginning. If they don't tell you negative and positive pi over 6, how do you find it? Okay, so first of all, let's switch to a different color. Let's switch to this green. Okay, so we have r equals to 3 times cosine of 3 theta, right? And then take a look. This one, right? This one is touching the 0. Are we good right there? That one is touching the 0. So that means we have to let this equals to 0. We have to set that equals to 0 and then solve for theta. And then once you divide both sides by 3, you have cosine of 3 theta equals to 0. 0 divided by 3 is equals to 0. Now, cosine of what is equals to 0? Okay, most people might just go ahead and do this. Okay, so you can say, okay, cosine pi over 2. Oh, there is a 3 pi over 2 equals to 0. Okay, can we do a pi over 2 equals to 3 theta, and then a 3 pi over 2 equals to 3 theta, and then just solve for theta. So this one you have theta equals to pi over 6. All right, so that one, what do you have? You have theta equals to pi over 2. Are we good? The answer is, according to your logic, that is right. But you have to think about the arc cosine. So this one, you actually have to think about inverse sine or arc cosine of 0 equals to 3 theta. And then you have to recall the graph of arc cosine. The graph of arc cosine. The arc cosine, so that one is from -1 to 1. That is on the x-axis. And then on the y-axis, the graph looks like this. And then the graph goes up to pi from 0, and this is pi over 2. So the 3 pi over 2, doesn't exist. There is no 3 pi over 2. So I should say, just put it right here, no 3 pi over 2. It will just go up to pi, not using an eraser. It will just go up to pi and then down to a y equals to 0. No 3 pi over 2. So that means this, no, no. So you only have a pi over 6. So, and then this the paddle is symmetric, so we go back to this problem. So we have a pi over 6 and negative pi over 6. So this paddle is bounded between pi over 6 and negative pi over 6. That's how you take care of the problem when they do not tell you what the fixed boundaries is. Okay, so now this is the end of this problem. If you think my instruction is clear and helpful, thumbs up for this video. Subscribe to my channel for more contents like that. As always, I will meet you all in the next lesson. Take care.